Okay, so let's start with this combined cycle power plant case for artificial intelligence basic journey. So as with any other machine learning project, we need to start with the business understanding, which in this case was very well defined for us. The goal is to build a project to predict the electrical energy output of a combined cycle power plant, or CCPP. Now, what are those? Well, they're basically systems of turbines that generate power or electricity and happen to be very efficient and also more ecological than other types of plants. Now here it was also important to understand the different factors that can influence the power that is being generated, and they're basically classified in two groups: short-term, that have to do more with the ambient conditions, and this is what this case is going to be about. But there are also some long-term effects, such as the component degradation and such as erosion, for instance. Now, out of this business understanding, there were two important takeaways. One of them was to be able to define the outcome, which in this case is to be able to have a prediction model about power produced, which that would be our outcome. And then the output, in this case, we are clearly talking about a regression model. So we're going to be using some metrics related to this type of models. So let's start with the data understanding. The database is there for us already. There's over 9,500 readings from a plant, and there are some as you can see down here, there are some factors such as temperature and humidity, and of course the information about the energy that is being produced. A quick look at the data set is telling us that all these variables are numbers basically, and that we don't seem to have a lot of missing values for now. As we continue with the data understanding, we have this table, with some statistics. The major takeaway, I will say, it's that in some instances we might have a situation of outliers when we look at the maximum values and the mean. So it's something that we'll need to check. And perhaps even more important, we have these graphs that are just showing the correlation between the different factors such as temperature and the energy that is being produced. And in some instances, like this one, we seem to have a very nice correlation, whereas in other cases, as here with pressure or with humidity, this correlation doesn't seem to be that precise or that aligned. We also have some variables that have this bimodal distribution. Visually, we can also generate these graphs just to identify that we do indeed have some outliers that we'll need to handle a little bit later. And perhaps, again, more important, we have this correlation matrix that is showing us two important things. One of them is that temperature is definitely the most important variable to predict the energy that is being generated, and also that between temperature and vacuum there seems to be a high correlation here. So we can have a case of multicollinearity that we also need to handle at some point. As we continue with the next phase, data preparation, as mentioned before, we took care of outliers. We just took a very simple approach. We removed the most extreme cases. It was only 3% of the total readings, so that was considered as okay, as a good way to go. And we can see from these graphs that yes, we don't have those outliers anymore, or those extreme outliers. In terms of the multicollinearity that we mentioned before, there were two steps. One of them was just to remove the vacuum variable, mainly because, as we discussed, it's highly correlated already with temperature. So we're not losing a lot of information from it, and it's just making noise. So that was removed, and then we also normalized all the independent variables. And with these two steps, we ran a couple of variance inflation factor calculations, and as we can see here, the before and the after, definitely these steps are helping us, as now we have these BIF values that are within 5 to 10, which is what we normally want when we're running this exercise here. And then looking at the correlation matrix again, we can see that this vacuum, of course, is no longer here, and the rest of the correlations seem to be adequate for our model now. When we go to modeling, as we mentioned before, we're talking about a regression approach, and we're going to be picking three models to compare. One of them is Mars, classic linear regression, and REACH. We also split our data set into using 20% into test and training data sets. And this, I'm going to walk you through what we did a little bit in more detail for Mars, but this exact same steps were taken for the other two models. And the first step was to create an original a model without any special modifications so that we can just use this as a reference. Then we tune up the hyperparameters, and we also apply some cross validation. And then after these two steps, we were able to generate a revised model that was the one that was used to make the final comparisons. Now, the outcome of the modeling, well, when we ran, for instance, a SHAP analysis, this was for Mars in specific, we can see, again, we're just confirming what we saw before, that temperature is definitely the most important a variable that is helping us to come up with these predictions. Here we have two examples of two data points that are just showing very similar behavior. And when we look at this graph, we can see that our predictions versus the original value, they're not that far. I mean, there's some cases. This might be some of the extreme kind of maybe some of the outliers that we have left here. But overall, the model seems to be performing in an acceptable way. And to make the comparisons, we look at as we mentioned before, for both the training data set and the test data set, we picked some of the most important regression metrics, such as MSE, R-square, and MAE, and we apply them to the three models that we picked. And just by looking at the numbers, the results that these calculations gave us, we ended up picking Mars as the model to be used if we were to continue with the deployment of this project.